towards are having momentum towards right. So the person in the ground frame, what will comment? And the person in the ground frame, you'll measure momentum. And you'll measure kinetic energy. Person in the C frame, you'll measure the momentum and kinetic energy. Then we'll see what actually, how things will appear for both the persons. Is it okay? So I'll begin like this. This is in the ground frame, what is the momentum of system? So with respect to G, I'll take like this. So with respect to, or in ground frame, what is the momentum of system? It should be 2 into 2 plus 4 into 3. So 16 kg meter per second or Newton second, anything you can write it. There's a momentum with respect to ground frame. What is the kinetic energy in the ground frame? 2 into 2 square by 2 plus mass of this 3 into 4 square by 2. 4 plus 28 joule. Now in the C frame, how things will be. So we'll first calculate velocity of center of mass. What is the velocity of center of mass? MA. And this should be 2 into 2 plus 3 into 4 by mass of the system 2 plus 3. 4 plus 12 by 5. So this should be equal to how much? 16 by 5 meter per second. What is this? Velocity of center of mass of system. Let's calculate velocity of particle A and B with us. So VAC. What is VAC? VA bar minus VC bar. Velocity of A is how much? 2 I cap. Velocity of center of mass 16 by 5 I cap. 5 to the 10 minus 6 by 5. Look at how they are minus 6 by 5. How the particle appears moving away. It all depends on calculations. It depends on values. Don't generalize. Please don't generalize anything. It all depends on the values. How do they appear moving? VBC. VB minus VC. What is VB? 4 I cap. 16 by 5 I cap. 20 minus 6. 4 by 5 I cap meter per second. In C frame, how A and B will appear moving. With respect to C frame, I'll write everything in. So the particle this is A, it'll be moving with a speed 6 by 5 meter per second. B, what will happen? 4 by 5 meter per second. And this is the center of mass. Of course, center of mass is also in motion, but I'm standing at center of mass where the person is here. So in C frame, what happened? What person on the ground, he said both are moving towards right, no? What is the comment from him? Both are moving towards right. So what this person says? They are moving opposite to, they're moving opposite to each other. And what is the velocity of center of mass? In fact, center of mass is moving. Center of mass is not at rest. Center of mass is moving. So you just show that we see here. And I'll bring it here. Okay, got this? So this is what happens. So in C frame, things are different. No? Let's calculate the momentum with respect to center of mass. Momentum with respect to, or kinetic energy with respect to center of mass. What should be the, I should write MA VC square by 2 plus MB VB square by 2. What is MA? value of MA, this is 2 kg, this is 3 kg. Yeah. 2 by 2, BAC is how much? 6 by 5. 3 by 2, this will be 4 by 5. 4 by 5 whole square. So 36 by 25, 3 by 2, 16 by 25. Anybody value? 8 by 5. Anybody value of this?
12 by 5.
12 by 5.
How much? 12 by 5.
12
Huh?
by 5.
Okay, 12
Yes,
by
sir.
5. Now check KC. Earlier was 28 joule, no? How much it is? Kinetic energy 12 by 5, very less, no? 2.4 joule. So in center of mass of system, what is the kinetic energy of that one? Is least, no? In the ground frame, how much the kinetic energy they measured? They measured 28 joules. In the center of mass, how much? 2.4 joules. So shall we conclude here? In center of mass frame, so what will happen to the kinetic energy of the system will be least. You check it. So Kc in fact less than Kg. So in C frame, kinetic energy of system you do have this statement in SC Verma. Students are just reading and remembering. You should do analyze. No, take simple examples. What about momentum with respect to center of mass? Minus MA, straight away let me write 2 into 6 by 5 I cap plus 3 into 4 by 5 I cap. Look at the momentum, 0, no? What is the conclusion? Momentum with respect to C frame. Momentum of system. Momentum of this particle system, momentum of particles with respect to C frame is 0. What is the net momentum measured by the person C who is there on the center of mass? And what is center of mass? Center of mass is moving, not at rest. You are in now C frame. And what you see, the momentum of system is 0. And the kinetic energy is minimum. Sir, how come this is something not, no? Means kinetic energy non-zero and momentum 0. Momentum of particles with respect to C frame is 0. With respect to C frame it is. C frame in center of mass frame here. So this is something very troublesome, no? Sir, kinetic energy non-zero. How momentum? And we know K equal to P square by 2m. In the ground frame, there was no problem. You see, momentum, what was the momentum of system? You can calculate momentum, how much it is equal to 4 I cap plus 4 into 3, 12. 16 I cap meter per second. Both kinetic energy as well as momentum are non-zero. What about in C frame? Kinetic energy is the least and the momentum with respect to center of mass will be 0. This is very important. Momentum with respect to center of mass will always be 0. If you want, you can solve in the C frame, problems will become very easy. You know total momentum should be 0. Then you can easily manage things. Now, so that's what finally, there's a one example I give. Now you take two particles moving opposite to each other. Make velocity of A greater than B, or so they'll let move opposite to each other. Let them move perpendicular. Check in all the cases what is the momentum. If it is 0 with the center of mass, then you have to say it's always 0. This is one of the case I discussed. Okay, tomorrow I'll continue from here.
Sir,
Uh,
sir, just a small doubt, sir. Sir, in the starting we discussed about ejection of mass, those problems, right, sir?
yeah.
Sir, we generalize that if a mass is ejected in the direction of motion, the speed of the system decreases, right?
Yeah.
Sir, similarly, if a system gains mass, can we say that it's exactly opposite to what we
No,
have
no,
generalized?
not. Don't generalize it.